Hello, our beautiful people, our esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab. That special channel of yours created for you and I to demystify mathematics and tackle the age-long phobia associated with this subject, one topic at a time. Today, which promises to be very exciting and fun, we are taking our topic again, indices. This time around, indicial equation leading to simultaneous equation is a very, very interesting topic, which I believe you're going to find quite enlightening. Without wasting time, let's dive in and enjoy the world of mathematics. Solve a pair of equations. The word pair in English, of course, means two. They come in twos. So simultaneous equations peculiarly come in twos. So that's why you normally see the word pair. So in other words, you're going to have two sets of equations, and from that meaning, you're going to get two answers. If it's more than two, we don't use pair, we say system of equations. Maybe you're looking for three or more variables. But in this case, we're just keeping it low to two variables, m and n. So how do we go? As usual, we resolve the indicial aspect before solving the simple equation aspect of it. We go here from this equation 1 here, or this first equation rather, we see that we have something common to the basis. What they have in common is 2. Please don't say 2 times 4. That would be very wrong because we don't have the same powers. So we have here 2 power m minus 1 times 2 power 2, which is a 4. So the idea is always to have the commonest base they have, which is 2 in this case. Then bracket m plus n equals 128 is 2 power 7. That's 128. So here we have the left hand side can now be simplified using the law of indices, which says that times is equivalent to plus. So we are going to have 2 power m minus 1 plus 2m plus 2n. I open the bracket there, equals 2 power 7. So invariably, I'm having on the left hand side, like times m plus 2m is 3m, then plus 2n minus 1 equals 2 to the power of 7. So I've simplified this to just this. Now we have, so it's pretty much the knowledge of previous classes that we're using here to add the same base. We now compare the powers, which is 3m plus 2n minus 1 equals 7. Writing properly, that's 3m plus 2n equals 7 plus 1, like terms. Hence, 3m plus 2n equals to 8. That's the best we can go for that. Then we call this equation 1 proper. Note, I said we're having a pair of equations. So we have gotten this one from the first equation given in the question. Thereafter, we move to the next one, which is 9 to the power of 2n minus m divided by 27 to the power of n minus 4 equals to 1. Again, what comes to mind here, what strikes us here is that the 9 and 27 have something in common, which is 3. So we have 3 to the power of 2, which is 9 anyway. Then we have what? 2n minus m divided by 3 to the power of 3, which is 27 anyway, n minus 4 equals to 1. Then by the law of indices, division becomes subtraction. That's 3 to the power of 4n minus 2m, opening this bracket. Then division minus, I'm having here 3 bracket n minus 4 equals, if we are to write this one as base of 3, that simply means 3 to the power of 0. We're using the concept of any value to the power of 0 is 1. So simplifying the left hand side properly, we're having 3 power 4n minus 2m minus 3n. Then be careful when you get to negative, be careful. Minus 3n, that's the first one. Then plus 12. Very careful. That's a point a lot of students actually fall. It's going to be minus times minus plus. Or some will actually not even multiply. They just say minus 3n minus 4. That's quite wrong. Be very careful about that. 3 power 0. So we just simplify the index. Ideally, we write them in terms of m coming before n. So we have minus 2m, then 4n minus 3n is plus 1n, then plus 12 equals 3 power 0. And again here, we can go further, equating the basis. We having an having the powers as 2n plus m plus 12 is 0, which will result in 2m plus n equals to minus 12. And there we have equation 2, as we can't go further. So we have simply resolved the initial aspects to pure simple linear equations. And this is a topic of interest, simultaneous equation. So in solving this, we just write out the two equations that we have and solve plainly. I believe there's no issue up to this point. It might be a bit technical, but it's better to take it slowly to avoid mistakes. So let's take equations 1 and 2 separately, and that's all. So equation 1 says 3m plus 2n is 8, while equation 2 says minus 2m plus n equals minus 12. So we are resolving these two equations by either of substitution method or elimination method, which I presume you have a good understanding of. So to solve by substitution, I'm going to say using equation 2, which is this, I can say making n the subject, the n is equals to minus 12 plus 2m. I call that equation 3, minus 12 plus 2m. And of course, I substitute, and that's where the name came from. Substitute 3 into 1. That means anywhere I see n, I simply use minus 12 plus 2m as a replacement. So I'm going to have in 1, 3m plus 2n equals to 8. Hence, 3m plus 2. What's n? Minus 12 plus 2m equals to 8. So everything becomes equation in just one unknown, which is m in this case. So I'm going to have 3m minus 24 plus 4m equals to 8. So simplifying this simple in the equation, I'm going to have 3m plus 4m equals to what? 8 plus 24. So 3m plus 4m is 7m. 8 plus 24 is 32. Therefore, m is what? 32 over 7. Then again, after getting our m, we can easily get our n by going back to equation 3. So we recall from 3 that n is minus 12 plus 2m. It's minus 12 plus 2. What's our m? 32 over 7. 32 over 7. That's minus 12 plus 64 over 7. When you simplify that, we're going to have minus 84 plus 64 over 7, which is minus 20 over 7. Therefore, m is 32 over 7 and n is minus 20 over 7. That's quite a mouthful. If you agree with me, this is quite interesting and quite a journey indeed. That's the essence of exponential equations leading to simultaneous equations. Quite lengthy indeed. But I believe you me, it's worth it. Really worth it. Why? So, I'm going to implore you to take your time to go through the video over and over. If you have any issue with any aspect, you can feel free to pause and go over it again. If you enjoy this lesson as much as I do, as I often say, please don't forget to subscribe, like, share, and most importantly, don't forget to turn on your notification button so you'll be the first to know once we drop a new video. Thank you and stay blessed.